Hey, what's going on, everyone? In this video, we are going to troubleshoot startup problems in a laptop motherboard. We're also going to cover the startup sequence. I believe it makes it easier to understand or to troubleshoot power on problems when you understand the startup sequence of the board. So let's get started. The first thing that we need to do, of course, we're assuming that you have isolated the problem to be the motherboard. The motherboard is not starting up, it's not powering on. You disassemble the laptop and you're ready to start troubleshooting why it's not powering on. This particular motherboard, I fixed it. The problem was the BIOS chip. It was not starting, so I had to replace the BIOS and reprogram the BIOS, and that fixed the problem. But I'm going to cover the steps that I took in order to isolate the problem. So the first thing that we need to do, we need to connect the charger. So I'm going to do that. I'm going to connect the charger on the board. I don't know if you can see it, but I should have 19 volts coming in into the board. Okay, so those are my 19 volts, 19.6. The next step, if you open the diagram of the schematics, notice that the first page, it has a diagram of the board. Here we have the CPU, which is an APU, which is that means that the graphics is integrated into the CPU. And we have the salt bridge here, which is also known as the PCH. And on this section here, we have the KVC, also known as the EC, which is the startup chip. It controls a keyboard, fan, a read-only memory. On this section, we have the power section. At the top, we have 3 volts and 5 volts, along with the page that you have to go to. So since we're troubleshooting startup problems or power on problems, we're assuming that there is a component on the board that went bad and is preventing the board from powering on. So we need to verify that we have all voltages present in order to allow the board to power on. So first thing that I'm going to do, I'm going to head over page 35 and check for 3 volts and 5 volts. So I'm going to say 35, and I'm going to zoom in into this section of the board. And notice here that we have PU7, which is a driver for these four MOSFETs here. These MOSFETs are responsible for 5 volt output. This is 5 volt S5, also known as 5 volt always. And on this side, we have 3 volt S5. So for the board, in order for the board to boot on or power on, it needs those voltages. Okay. So the next thing that we're going to do, we're going to come here to pin 8 and pin 3, which is reference voltage. Actually, it's pin 8 and pin 17, which is 3 volt PCU and 5 volt PCU. These two voltages need to be present as soon as you plugged in the charger. So you should have 19 volts here. So coming in into this IC, and then we should be able to get 3 volts and 5 volts. So let's go ahead and do that. We need to locate PU7. So I'm going to go into BoardView, do Control F, and I'm looking for PU7. Again, I'm not familiar with the board. If you're familiar with the board, you can get away with not using BoardView. And this is PU7 here. Okay, it's really close to the 19 volt charger connector. It should be this pin here. So it should be the third one from the right. So that's uh, 1, 2, and 3. And I have 19 bolts there. I'm sorry, you can't see the multimeter, but my 19 bolts are there. The next step is to check for 3-volt PCU and 5-volt PCU. That will be pin A and 17. So let's go back. So 17 is right here. As you can see, if you hover over the pin number, it tells you the voltage, which is 5-volt PCU. So let's go ahead and check pin 8. That is the second one on this side here. I should have 3 volts there. Okay, so that's my 3 volts are present there. The next step is to check that the power button is getting the 3 volts. So let me go back into 35. Let me go back into 33. And if you come here to, this is the KVC or the EC startup chip. If you come to pin 125 of the startup chip, you see this pin here that says NB switch on. That's the power button. So it comes from the power button. As soon as you press the power button, you should have a low or a drop of voltage in this pin, and that's what activates this chip and starts the boot up process of the power on process of the motherboard. So the next step we're going to do, we're going to go to the startup chip, the section here that says wake up, and we're going to measure if we're getting 3 volts on pin 125. So this is the startup chip, this IC here. Let me bring it under the microscope. And we need to find pin 125. Again, if you don't know where a specific IC is, you can always get the IC number. This one is PU. This one is U16. And then go to BoardView, Control F, U16. Press enter. All right. So this time we were able to find it. And we're looking for pin 125. We're going to click on pin 125. And as you can see, pin 125 is on this section here. And it also shows the connection. And the connection are going to CN7, which is the power button. CN7. This is the power button here. This is CN7, and it's connected to pin 125. So let's do that. Let's check that we have 3 volts on pin 125. This is pin 128, so it'll be 27, 26, and 25. Is the 4th pin. Should be this one here. And as you can see, I have 3 volts. The reason that you see minus 3 volts is because notice that I have the positive on the ground and the negative, but it's 3 volts. So as soon as we press the power button, that voltage is going to go away. We're going to have the drop on that pin. So I'm going to press the power button. And as you can see now, the fan, I didn't press it long enough. You can see now the fan is spinning. So that is good news. Let's go back into the schematic. and continue with the power sequence. Now the next step, as soon as you press the power button, you need to enable the 3 volts always and the 5 volts always. And the IC, this EC, the KVC, the startup chip, or the embedded controller outputs at 3 volts here. Actually, it is right here on pin 48, S5 on, which you can, this number here, this is the page where this connection is going to. So if we go back into page 35, and notice that is my charger circuit, which is responsible for outputting 5 volt S5 and 3 volt S5. And that pin from pin 45, I think, it's coming right here. See, it says S on pin 18, which is the enable sequence. And as soon as it receives the enable sequence, then this IC, which is the driver for this MOSFETs, it's going to give you the 3 volt S5 and 5 volt S5. Okay, so let's go ahead and check that. Again, we're looking for pin. What was the pin number? We're looking at the this is PU7, which is connected to the EC. PU7 pin 16, pin 18. Control F, PU7. Then we're looking for pin 18, which is this one. Yep, pin 18. And let's go ahead and measure. We should have 3 volts here. Of course, you can skip this step and go directly into 5 volts and 3 volts. And obviously, if you have those voltages, everything is working here. And at this stage, notice that the fan is spinning. So as soon as you press the power button, the EC loads the BIOS program, talks to the BIOS, loads the program, and initiates the startup sequence for the board. So let's go back into the microscope, and this time I'm looking for this chip right there. Which is PU7, and the pin number is pin 18. And I should have 3 volts there. Why is it important to check for all these things? Well, maybe, so that's my 3 volts there. Maybe you press the power button and for some reason you don't have 5 volts S5 and 3 volt S5. So if you don't have 3 volts and 5 volt and 5 volt S5, the board is not going to come on. So you need to isolate the problem, whether it's this IC PU7 or is the EC, the embedded controller, because as soon as you press the power button, the embedded controller receives the startup sequence and sends an enabled signal 3 volts to pin 18, and it then enables this chip, and then it will give you the 5 volts and 3 volt S5, and this 3 volts and 5 volt SI is what's going to power on the rest of the board, especially the PL, I believe is the south bridge. And so next we're going to measure for these two voltages at the output of PL24, which is a coil, and PL25. So that's the next thing that we're going to look for. We're looking for PL25. All right, so we found it. It should be at the big it should be somewhere near the charger. This is PL25 and PL24, and I believe it's on the other side of the board. So I'm going to go ahead and flip the board. And it is those two big square. So you see how it says on the board PL25, or actually PL24, right here. See if I can, right there, it says PL24. I know that the resolution is not the best. Let me see if I can. Okay, here we go. So again, I'm going to look for 5 volts. All right, so I have 5 volts there. I don't know if you can see it on the meter. And then I'm going to look for 3 volts on the other coil, which is this one here. And then I have 3 volts. All right, so it is safe to say that my power supply is working. It's giving me 3 volts S5 and 5 volt S5. And the power sequence at this point is basically complete. You can, in this particular board, I was not getting my 3 volt S5 and 5 volt S5, and also I was not getting the enable signal from the embedded controller to enable this charger IC. So I isolated the problem to either be this S5 on after I press the power button. I had in this board I had my 3 volts coming from the power supply, and as soon as I pressed the power button, I had the drop down voltage, but then I did not have my S5 on enable voltage for the charger circuit that is going to give me 3 volt S5 and 5 volt S5s. So I isolated the problem to either be the embedded controller or the BIOS chip. As you can see, this one, the U19, actually, it's this one here, U20, is the BIOS chip. And I decided to go with the simple fix first, which was to replace the BIOS, and eventually, and that fixed the problem. So let me look for the BIOS, U20. And notice that the BIOS chip is it's right next to the EC. So if I flip the board, this is the BIOS chip here. And this is the EC, or the embedded controller, also known as the startup chip. So I decided to replace this one. I got a new BIOS chip, reprogrammed it. I downloaded the program from the hardware manufacturer. So if this is an HP laptop, so I went to HP support, find the BIOS program, download it, reprogram it. I'm going to make a separate video on how to reprogram the BIOS chip and then replace it. And as soon as I replace it, the board was fixed. Before finishing this video, I wanted to mention a couple of other things that you need to check for when having power on issues, especially related to the EC, the embedded controller. There is several voltages that we need to check for. For example, before even starting replacing anything, you should check for the existence of 3-volt PCU, which we check at the beginning of the video. If we have 3-volt coming from the charger, it's very likely that you're going to have 3 volts VCC coming into the EC. Without these 3 volts, the EC will not be able to work. So that's one. Another very important thing to check is for EC power OK. You should check for this 124, pin 124. What else? The lead, this voltage here is the voltage that you have when the lead, I believe, is open. AC in, this is when you plug in the charger. You should have on pin 21 voltage. Another very important voltage to check here is this RSM RST, which is this pin 123 is connected to the PCH or the south bridge. And as soon as the south bridge gets power, it'll put a voltage on this pin here. This is a good indication that the PCH is working and has communication with the EC, the embedded controller. So that is the power sequence that I wanted to cover. Again, thanks for watching this video and see you in the next video.